Okay, let us see some examples here where we can see applications of Lami's theorem. We have seen one in the previous lesson. Let us see another two in this lesson. So, find t and z in the following. So, we have z here, we have t here. They are giving us that force there. Of course, now, if we need only one force and then the angle opposite it. So, if this is 90 and this is 120, it means that now this balance here, we can able get that balance. So meaning, if I'm to draw that, I draw this, I'll be having, this is going to be my 80 newtons, this is going to be 90, which I want, this is 90, this is 120 degrees, Z, it's going to be my Z. So you see that now, the balance here, if this is 90, and this is 120, say the overall should be 360. So if this plus this would be 210, and so meaning the balance here is going to be 150 degrees because it's 90 plus 120 will give you the balance. So now my t, so that t, we have the angle opposite it, and we also have z. So t over sine of 120 will be equal to now 8 over sine of the angle opposite it, which is 150. And so our t will be now 8 sine 120 the whole over sine 150. And so our t is going to be, this is 150. So it's going to give me 8 newtons. Okay. It's giving me 13.8564 newtons with this. When I come now to my z, is that my z over sine of the angle opposite 90 degrees equal to now 80 over the sine opposite it, which is sine this angle will put as 150 degrees. So this is 1, and so our z will be 8 sine 90, but sine 90 is 1 over sine 150 degrees, and so our z will be there, which would be 16 newtons with this. But those two. Then here we have an uniform load of mass 9 kilograms rests on rests horizontally in equilibrium, supported by 2 light inextensible springs tied to the ends of the rod. So now in our solution, we start by sketching that. So we have a rod, a non-uniform rod. We shall see what non-uniform means. It can't balance on its own. So this one is having weight 9 kilograms, meaning it's going to be having a weight factor on it as 9 g, because it has a mass. Supported by 2 inextensible springs, so I'm going to consider this as one spring, and then I'm going to consider this as the second string. So 9 kilograms rests horizontally on equilibrium, supported by 2 light inextensible. So inextensible tied on ends of the rod. So they are tied on ends of the rod. So this one is going to be string 1, and this will be string 2. So they are supporting this. The strings make angles of 50 degrees, so let us consider this to be 50 degrees and 60 degrees with the rod. I think you see that these are the strings with the rod. Added the tensions in the string, so meaning we are going to be having tensions in this string. So we are going to be having that tension there acting like that. So this one is going to be T2 if this is T1. So now here is an application of Lami's theorem. So how do we get this here? Now here, you just need to see that if you have that, you can generate now Lami's. Now, allow me to start with this force here. If you see that now, this is what we are going to do. You look at this. If I bring that force, that diagram here, this one is 50 degrees. This one is T1, and I also have 60 degrees. This one is going to be T2, and I have a force of 9G acting the weight of that rod. Now, this one means I can now, if I want to start with this, remember this one is 90, of course force is acting orange, so this one is 90 degrees there. Now, I can bring all these forces here. Look at this. If I bring this, the 9G here, and then I bring this one here, remember this is a straight line, and I bring this force here, this one is going to be 91. Now, because we are seeing if this force here, from here, remember this one, from here, the balance is going to be 130 degrees. And then this one, remember it was 120 degrees. Meaning, first of all, this one here is 90. From here, this one is 90. Then if I have this as 90, remember now, this one, we are having it as 50. But remember, the balance for this was 120. So, if this is 50, like this, if this is now going to be 50 for this T, this is going to be our 50 degrees. But remember, this one had a balance. Remember when I had this one here at 60. So the balance here was 120 degrees. This balance here was 120 degrees. Meaning, if you take away this 50, now here what is going to be the balance. It means that now this will be 60, and this is, if this is 50, that is 110. But remember the whole line is having 108. So meaning the balance here is going to be 70 degrees. And so I have created that force. Now it means that now this force, now this is going to be 90 degrees. So meaning I'll add this and this, I'll be having the overall angle there, this and this, then I'll be having the overall angle there. So if I'm to sketch now that diagram, I'm going to be having something like this. I'm going to be having this one. Now this one is going to be my T1. This one is going to be my T2. And this one is going to be my 9B. Now, this one, I think you can see, it is 70 degrees. Then this one here, we shall add 50. The whole of this, when we add 50 plus 90 degrees, which will give us 140 degrees. So this will be 140 degrees. Then here, we shall add 60 plus 9, which gives us 150 degrees. So here, we have 150 degrees. And so there, we can every use Lami's theorem. So from here, you can see now that 92, let me start with T2, over sine of the angle opposite, sine 140 degrees will be equal to there, because you know this 9B, the whole over the opposite angle, sine of the opposite angle, and there you can get our T2 as 9 into 9.8, then cross multiply sine 40 degrees, the whole over sine 70 degrees, and you can get our T2 for decimal places in newtons. Okay, when I come to my T1 angle opposite is sine 150 degrees. Will be equal to this one, we know it, 9B over the sine of the angle opposite to it. And so the number is that. So our T1 here is going to be 9 into 9.8, then sine 150 degrees, the whole over sine 70 degrees. And so our T1 here is going to be, we are going to give that in newtons. So this one is going to be 9 into 9.8 sine 140 divided by sine 70. So the answer I am getting is 60.3324 newtons. And then here we press in this 5, so this will give us 46.9302 newtons. And so we have got the tensions in those two springs there. So that's how we handle that. I wish you well. We are going to see more examples still about this Lami theorem. See you there.